Okay, this is Unit 4 on similarity, Target 5, using the triangle proportionality theorem. I'm going to make a couple different videos to go with the lesson for you. Okay, the triangle proportionality theorem talks about there being a parallel line inside a triangle. So essentially, we're taking one line, in this case TU, and we're drawing it in such a way that it's parallel to one of the sides of the triangle. When that happens, the triangle proportionality theorem says that it divides the other two sides proportionally. So the yellow over the green is going to equal the blue over the pink. When it says that it divides them proportionally, it means that the yellow over the green is going to have the same ratio, so as a fraction, that the blue over the pink is going to have. The converse to the theorem says that if this is true, if we know that the sides are proportional, that means that the line drawn in the triangle has to be, in fact, parallel. So here's some examples of using that theorem. This goes with the worksheet or the note sheet that was handed out in class. So number one, we're trying to find this missing side length, RQ. RQ is right here. Okay, we call that segment RQ. But then when we're trying to find the length of it, we just refer to it with the letters RQ. RQ means the length of the segment RQ, or it means the distance between the points RQ. So because we have these parallel line symbols, because the lines are parallel, they have to be parallel. Because the lines are parallel, we can set up all of the sides into a proportion. So I've highlighted the yellow. Now QU is going to be in green, RS is going to be in blue, and ST is going to be in pink. What this allows me to do is set up a proportion. Yellow over green is going to equal blue over pink. So yellow is RQ, and that's over 9. So I took this part and this part, the two parts. The parallel lines divided that segment into two parts. So RQ over 9 has to equal 4 over 6, because that's divided into two parts from the parallel lines. And the parts, yellow-green and blue-pink, have to be proportional. So in a proportion, you can solve different ways. Middle school uses the fish method, which is just a way you're drawing your steps, but that depends on what's going on. Really, I can multiply both sides by 9 and be done, but I can also always cross multiply. So 6 times RQ is equal to 9 times 4. So 6 times RQ is equal to 36. Divide both sides by 6, and RQ is equal to 6. So 6 over 9 has a ratio of 2/3. 4 over 6 has a ratio of 2/3. Here's a second example. Okay, this time I'm going to find ZY. Okay, ZY is again in yellow. The part that it's next to is YX, that's 36. VW is a part, that's 35. And WX is a part, that's 44. So again, I can do yellow over green equals blue over pink, or I could do it the other way. Green over yellow equals pink over blue. And there's another way you could set it up too, but I'm just going to keep this simple, or try to. So I'm going to say ZY, the part I want, divided by 36 has to equal, since I did ZY, which was down here, I need to do the 35, which is also to the left. So 35 is on top, and 44 is on bottom. In other words, the 36 was on bottom because it was the right part of this bigger segment. So the 44 is also on bottom because it's the right part of the two segments. Blue and pink, blue's on the left, pink's on the right. Yellow and green, yellow's on the left, green is on the right. So I can cross multiply. 36 times 35 is 1,260, or 1,260. That's equal to 44 times ZY. So divide both sides by 44, and I get ZY equals 28.63, and the 6 3 are repeating. Your calculator can turn that into a fraction or multiple fractions. So you can also write that as 315 elevenths. Or if you really like mixed numbers, you can write that as 28 and 7 elevenths. I'm okay personally with all three answers, but I also expect that you can get any of those three answers with your calculator. So your calculator skills may need to improve. And then the last problem, number 3, using the converse, determine whether the lines are actually parallel. So the way we check for that is doing the same thing we did on the last problem. We need to show that 90 over 50 does in fact equal, so I'm putting a question mark because maybe it does, maybe it doesn't, equal 72 over 40. So again, I did left over right of my top segment and then left over right of my bottom. So I can type those into my calculator as fractions and see that they both simplify to 9/5. 9/5 equals 9/5. I could also take those with the calculator and divide. 9/5, 90 divided by 50 would be 1.8, and 72 divided by 40 is also 1.8. So yes, because they are proportional, it means that those segments are parallel.